Let's solve easy problem from the LeetCode. It's a number of 1 bits. We'll see a different approach to solve this problem. In this way, we'll get ideas to deal with this binary operation in with different ways. So the problem here is, for this 11, if you see the binary representation for this 11 is 1011, and in this string we have like 3 1, and that's the result. So we need to count the number of 1 in the binary representation of this number. So one of the approach here, let me uncomment this code. In this there is a b here. I give b and the number in the Golang. This returns the string binary representation of that number, and I'll also show you how we do in a Java. And once we get this string, then after that we can iterate and we can count this one, and that's what exactly I have done here. So iterating over there and checking it's a 1 and the count plus plus, and I return that, and in this way we can count the number of 1 in that number. So let's run it, accept it, submit it. Okay, we can see another approach. Let me comment this. So in the approach 2, let's understand this. For 11, how we usually do the math to find the binary representation of this number. So we usually divide this number by 2. So when I divide this by 2, then I will get 1 remainder, and then we have the 5. Again, we divide 5 by 2, then we'll get 1 remainder, and now we have number is 2, and from in the 2 again we divide by 2, we'll get the remainder 0, and the number is 1, and this 1011 is the binary representation. I have used exactly the same logic. I'm checking n not equal to 0, and I'm getting the remainder, and if the remainder is 1, count plus plus, otherwise we'll reduce this number, so n by 2. So this is first 11 and 5, 2 and 1, so that we get here. And then finally, if you divide n by 2 again, we'll get the 0 and come out of this loop, and we'll get this return count. So that's the another way to count number of 1 in the number. So let's run it, submit. Let's see the third approach. Let me comment this code. And third approach, let's understand this, and then we'll come to the code. So for 11, the binary representation is 1011, and in the left side there will be all 0000. If it is if you consider that in a 32-bit, then in a 32-bit in the left side all 00 and 1011. So we have to run a loop for 32 times, and then we need to prepare the mask. So the mask is like, let's say the number 1, and for the 1 I can represent this in a different way with the 4 digit. I can say just 001, and the first time I will do the left shift by 0. So in a 1, this is a 1 representation, and in a 1, if I left shift by 0, 1 will be here itself. So in this case, that this number will look like this 001, and then with this 1 bit and 1 bit, this, if I do the AND operation, so that's the AND operation. When I do the AND operation, then AND operation with this number and the mask what we prepared, will get 1. So 1 and 1, that value is 1 with the AND operation. So 1 and 1 will get the 1. So that means we get the 1 and the counter is 1. Next time we'll shift 1 by another number 1. So if I shift this 1 by 1, then this 1 comes here, and this is become 0. So now we have the 0010, so 010. So in this case, if I AND this mask, if I AND this mask with the actual number, then in this bit 1 and 1, that is the 1. So the counter will be 2. Again, next time we'll shift this 1 by 2, then that will be 100. This number will, this 1 will be shift here and it will come here. And in this case we'll AND 0 and 1, and in this case counter will not increase because 0 1 will be 0 when we do the AND operation. Next time again we shift this by 3, 1 by 3, then 1 comes to this place, and then 1 and 1 when we do the AND, then that becomes 1 and the counter is 3, and that's the answer. Next time again if you do left shift by 4, 1 will come here left side, but this value is the 0 and 0 1 all will be 0 and 0. So that's what I'm doing here. I'm running this loop from 0 to 31 and I'm preparing the mask. So this one, left shift by 0, left shift by 1 2 3, and I'm masking, and then I'm ANDing that mask with actual number. I'm checking it's not 0, then count plus plus, and at the end we can return the count. So that's the another approach. Let me refresh this page. Okay, so I think this this can be due to the internet issue. Spending. Okay, we'll come back, we'll see the another approach, and again it's working, and we can see that also. So in another approach 4, in the approach 4 is in a, for this number, when we do the AND with the n and the n minus 1. So that's another very easiest way to solve this. So when I do n and n minus 1 AND, as long as this is greater than 0, and we'll keep incrementing this count. So in this way, you know, when we do that then it will count actually the number of 1 in the in that string or binary representation of this number. So this is the another approach. We can do this. So this is the Golang solution. Here we can see the Java solutions also. Okay. So let's run this code again. Yeah, that's also okay. Just comment this and approach 4 uncomment. Yeah, that's submitted. Okay, so you know, in a many other bitwise operation, we need to find out, you know, the bit is the count of the bit, and that's we can utilize this code, and we can use any approach, but this is also very handy. You know, just do the number n and n minus 1 and the count plus plus, and this will return the count of the 1. Let's see the Java solution for the same. So approach 1, integer to binary string, and then we got the string, and then we counted the 1 and the count plus plus. So that's approach 1. Approach 2, exactly in the same way, getting the remainder, and remainder is 1, count plus plus. Approach 3 is exactly same way. So in a Golang program, I started with a 0, and here I started with 31. So in a both way, we can use the mask. And this logic is exactly same. We can do the n and n minus 1 and the count plus plus, and in that way we can count the number of 1 in the numbers. So let's run this also. Okay, so that's all for now. Thank you.